All right, ladies and gentlemen, so far we have now looked at two different ways that we can show that triangles are similar. If all three of the sides form the same ratio, we can say they're similar. If I have two angles that are congruent, we can say they're similar. Well, now we're going to have a third way. So if I have one pair of corresponding angles are equal, I can also use the side lengths to show that they have to have the same, that they're also similar. So I have one pair of corresponding angles and the ratios of the corresponding sides are equal. But you have to have two pairs for that. All right, so let's see what we're talking about here. So based on this picture, right, we have two triangles, ABC, A prime, B prime, C prime. We have some measurements. So I want to know, are these two things similar? So what I have here is I have one pair of angles. So I know that angle B is congruent to angle B prime. Right, those are the same, pretty easy to read that. So now what I have to show is that the sides, because I don't have three sides, I only have two. So I can do two sides and one of the angles. So I'm going to set up and see if I can do my same scale factor. So I have to do 12.72 over 5.3, image over pre-image. And you need to start bringing your calculators with you to watch these. That gives me a scale factor of 2.4. Now I'm going to check it with the other one, with BC and BC prime. So I'm going to have 11.04 divided by 4.6, and I do get 2.4. So are they similar? Yes. I have one pair of congruent angles, and the same scale factor for two pairs of sides. I definitely did not leave myself enough room. Sorry about that. All right, now that we know, we've shown that they are similar, now I can use the scale factor of 2.4 to help me solve this problem. So I want to know, assume the length of side AC is 4.3. I want to know, what is that side? A prime, C prime. So now I'm going from image, pre-image to image, so I have to multiply by the scale factor, which is going to give me 10.32. And again, I did that all in the calculator. All right, let's try another one. So here we have this lovely picture, and one of the first things, I always want to look for the easiest way. The easiest way is to see if I have two angles that are congruent. So I have 92 and 92. I have 59 and 59. That is enough for me to say that they are similar. This should say triangle A prime, B prime, C prime. Wrong thing there. So based on the information given, is it similar? Yes. I have two pairs of congruent angles. Okay, so now that we know they're similar, I want to determine the length of A prime, C prime. Well, in order to do that, right, here is A prime, C prime, I have to know what the scale factor is. So I have to match up. I have a lot of different sides here, but I have to match up the ones that go together. AB goes with AB prime. So I have to do my scale factor. So I'm going to do that over here, just so I have a little bit more room. Image over pre-image. And when I divide that out, I should get 1.6. Right? So there's your scale factor. There's K. So if I want A prime, C prime, I have to take AC, 6.1, multiply it by the scale factor, which gives me 9.76. Given that they are similar, now I want to know, well, what's the length of BC? So now I'm going backwards. Now I'm going from image to pre-image, which means I have to divide by my scale factor. So here is CB prime, 8.96. I have to divide it by the scale factor, and that gives me 5.6. Right? So we have to be able to use that scale factor and go from one way to the other. All right, so now here's another picture. But in this picture now, instead of them being two totally separate triangles, one's inside the other. So here is my A prime, B prime, C prime. And then here's the big one, right? So clearly this is a reduction. All right? Hopefully you can see that. So based on the information, is ABC similar to A prime, B prime, C prime? Well, I have to be able to show either that I have two equal angles, or I have the sides are in the same proportion, or I have two pairs of sides. Well, here's my problem, is I have this pair of sides that I can compare, but I can't compare AB and AC, two different sides. I only have this, right? Angle A is equal to itself. I have that angle, but that's about it. All right, so right now, no. I can't, not enough information. There we go. I don't have enough information there. Part B, assume that line BC is parallel to B prime, C prime. So now we're saying, oh, now I have parallel lines. And when I have parallel lines, and then this one is my transversal, I know that this angle is congruent to this angle. Now I have enough information. So now can I say, yes, I have two pairs of congruent angles. Right, I can say that. All right, given that they are similar, determine the length of side A prime, C prime. So again, just like I had to do up top, I have to first now go through and figure out what my scale factor is. And for the scale factor, we have to use the two sides that match. So this time it's image over pre-image. So 2 over 8, which is 1/4. What I wanted to write. Or you could say it's 0.25. So that's your scale factor. Okay. So now I'm going to use that to find AC prime. So here's AC. So I have to do 6 times my scale factor. I'm going to do it as a decimal. You can enter it as a fraction. It doesn't matter to me. I don't care. So 6 times 0.25 is going to give me 1.5. Given that they're similar, determine the length of side AB. So again, this time I'm going to go backwards. So I have to take, here's AB, 2.7, and I have to divide by my scale factor, 0.25. And that is going to give me 10.8, which makes sense because in this case, it was a reduction, so our image is smaller than our pre-image. All right, so that's about it. Hopefully, it's just kind of tying things together. You have to be able to know how to figure out if these two things are similar. But if you have any questions, you know that you need to bring them to class. Have a good night.